Hello everybody. Today we are going to be talking about and adding on to this idea of limits, where we break things down and look at really small pieces close to numbers. It's going to be the foundation of calculus, and today we're going to talk about finding a limit algebraically. Through this video series I have touched on problem spots, and a lot of the ones that, when we find problem spots, direct substitution doesn't necessarily work, although that should always be your main tool, the first tool you use. But sometimes we have to get a little bit more creative. So I've already talked to you about finding limits graphically, finding limits numerically, but I also have an algebraic strategy, or there is also, I don't have it, I am just a teacher of this stuff. But algebraic techniques can help us out as well. And if you think back to the background skills, one of the things we talked about is factoring. And so that is what we are going to end up using here. So use direct substitution to determine if a value is a problem spot. That's going to be our first step. So if I plug in a 0 here, I would end up getting 0 squared divided by 0 squared plus 5 times 0, which is 0 over 0. And if you remember back to L5, that is an indeterminate form, which means it's a problem spot. We're dividing by 0. We don't want to divide by 0. So that's why I'm going to use this algebraic technique. Now, limits can be rewritten. So the limit as x approaches 0 of x squared divided by, instead of, do you see how in the bottom both terms have an x in common? So I can factor that out and rewrite this as x times x plus 5. Now, if I do that, x times x plus 5, notice that I have an x that can be simplified to a 1 over a 1. So instead of writing this as x squared divided by x, I can rewrite this as x divided by 1. So then I have the limit as x approaches 0 of x divided by x plus 5. Now, what you'll notice is that this is no longer a problem spot. Okay? I can now plug in my 0, and I would end up with 0 divided by 0 plus 5, which is equal to 0. Okay? That's a value that's perfectly acceptable as a solution here. So what I want to do is just, I don't know, a lot of times students get zeros and they panic and think, oh, I must have done something wrong. Oh, the limit does not exist. No, 0 is a number. You can have $0 in your wallet. It happens all the time to me. So just work through that, okay? Next thing, so I factored out a common term here. I can also factor the top and the bottom, see if that helps me out. Again, if I plug in a 4 here, I will end up with 0 over 0, indeterminate form. I have a D&E that is problematic. So what I'm going to do is I'm going to go through and I'm going to rewrite this limit. The limit is x approaches 4 of, all right, I need two values that multiply to negative 40 and add to positive 6. That's going to be x plus 10 and x minus 4. Multiply to negative 40, add to 6. Got that taken care of. The bottom is going to be two values that multiply to 4 and add to negative 3. So that's going to be x plus 1 and x minus 4. Now, notice I have x minus 4 divided by x minus 4, and anything divided by itself is equal to 1. So I can simplify those so that they are equal to 1. If I do that, I have the limit as x approaches 4 of x plus 10 divided by x plus 1. And I can try my direct substitution technique again, which would give me 4 plus 10 divided by 4 plus 1, which is equal to 14 over 5. And that is the final solution to my limit. Okay, so again, if we plug in, get something that's bad, we're dealing with a problem spot, we can try to factor out. That's the first technique. The second technique for working through things algebraically is rationalizing the numerator. Okay, what you're going to do is multiply the top and the bottom by the numerator's complex conjugate. If you don't know what a complex conjugate is, it's the same thing, except for instead of a minus, I'm going to multiply by a plus in both of these. Okay, you'll distribute the top but not the bottom. You'll combine your like terms and cancel out common factors. Hopefully the bad spot is canceled out, and you'll use direct substitution to evaluate the limit. Again, we don't want to do this unless it's a problem spot. X, if I plug in a 4 here, I'd get 4 minus 4 in the bottom. That's going to be 0. Can't divide by 0. So that's a problem spot. So what I'm going to do is multiply by the square root of x plus 5 plus 3 divided by the square root of x plus 5 plus 3. Now, what is this going to end up looking like for me? Well, I'm just going to FOIL this. The square root of x plus 5 times the square root of x plus 5 is, sorry, I want to make sure I am technical and write my limit. Got a big fraction. Square root of x plus 5 times the square root of x plus 5 is x plus 5. Square root of x plus 5 times 3 is 3 root x plus 5. Square root of x plus 5 times negative 3 is negative 3 root x plus 5. That's why we use the complex conjugate, so that we can cancel those out. And then I'm going to get negative 3 times 3, which is a minus 9. And then in the bottom, remember I said do not distribute. That'll give me the square root of x plus 5 plus 3. Okay. So as I go through here, I'm just going to clean this guy up a little bit. The limit as x approaches 4 of x minus 4 divided by x minus 4 times the square root of x plus 5 plus 3. And if you look at that, again, I have x minus 4 in the top, x minus 4 in the bottom. That simplifies to 1 over 1. So I'm left with the limit as x approaches 4 of 1 divided by the square root of x plus 5 plus 3. And now my 4 is no longer a problem spot, so I can use direct substitution. I'm left with 1 divided by the square root of 4 plus 5 plus 3. 4 plus 5 is 9. Square root of 9 is 3. 1 over 3 plus 3 is 1 over 6. Okay. If you want to pause the video here and try this next one on your own, I think that's probably a good idea. I would suggest that. I'm going to go through this problem. Same exact technique, just different numbers, just so you can see it a second time. So, again, complex conjugate, x plus 1 plus 1. Square root of x plus 1 plus 1. Sorry, I skipped over something. I'm plugging 0 in, and I have a single x in the bottom, which would give me an x in the bottom. So it's a problem spot. We're going to use rationalizing the numerator as our technique. This is the limit as x approaches 0 of, again, I'm going to FOIL. I probably won't quite show as many steps this time. But I'm going to FOIL x plus root x plus 1 times root x plus 1 is x plus 1. The middle terms are going to cancel out, and then negative 1 times positive 1 is a minus 1, divided by x times the quantity of x plus 1 plus 1. X plus 1 minus 1 is just x. X divided by x is 1. So these guys go to 0. Then once those go to 0, those go to 1s, so I don't need to write those in my equation. And I'm left with the limit as x approaches 0 of 1 divided by the square root of x plus 1 plus 1. Okay, 0 is no longer a problem spot, so I can plug it in. 1 divided by square root of 0 plus 1 plus 1. 0 plus 1 is 1, square root of 1 is 1, and 1 divided by 1 plus 1 is 1 over 2. So what we're doing with both of these skills as we go through is basically we're rewriting our function as a different function that's the same minus the 1 point that we're taking out, the 1 problem spot. So that's why this works. And recognizing which case to use when. If you've got this big square root thing in the top, that's probably a good hint that rationalizing the numerator is going to be your technique. If you have stuff that looks like it can factor, that's going to be a good hint that canceling out common terms and factoring is going to be your hint. Remember, this all centers around problem spots. We've got a couple algebraic techniques so that if things aren't working out super well, we can get it figured out. I know this video was a little bit longer, but there was a lot to it, so I hope that helps, and I hope you guys are having success with this.